Hi guys, welcome back to my channel. I know I haven't posted in a long time, but I just thought I would do something different this time around. And it's kind of like a code with me as I go along kind of thing. I haven't really planned it out yet. But basically what I'm planning on doing in this video is implementing a box blur from scratch using a Python library called Pillow. And so essentially how it works is that, so I have Paint pulled up here with an example image, right? What a box blur does. So let's say I divide this up into separate, uh, let's call these pixels. They're not exactly pixel size, but just call them pixels just for the sake of the explanation. Or let's call them boxes actually. Okay, so the way this kind of blur works is that, let's say we are trying to apply the blur for this pixel right here. What we would do is that we would look at the RGB value. So RGB is the red, green, blue values for all these separate pixels around this pixel right here. And what we do is that we would average all these RGB values together to get a new RGB value for this pixel right here. And so in this way, we're kind of just averaging out all the pixel values from the surrounding pixels to create some sort of box where the average is, applied to just that center pixel right there. So that's kind of what we're going to be implementing in Python today, and that's kind of the concept here. So what we're going to start off by doing is just actually getting a little familiar with the Python library itself. So we're actually going to open up a new code editor, make a new file, and the import here is actually PIL for pillow. So we're actually going to do from pillow import image. Let's just say that. So what we're going to do is we're actually going to get this image in this folder real quick. See that? Okay. All right. So as you can see, I have this image in my coding folder right now. So what I'm going to do is actually I'm going to have to open the image using pillow. So let's say img is equal to image.open, and this image is a picture of Ronaldo, and we will open it like this. And I'm just gonna, just to make sure it works, I'm gonna do run image.show. So save this file, let's run it, and as you can see, the image shows. So we have got the image successfully loaded in our code. Now, the way that it worked, like we just said, we're actually gonna basically just loop over all these pixels in the image and just run this operation separately for all of them. Now, what you'll see in a second here is that it's going to be a little bit different for the pixels on the edges, because as I mentioned, this pixel right here, obviously it has all the neighbors, like all the neighbors exist near it, right? But what if we were trying to do it for this pixel right here? Now obviously you have these neighboring pixels, but you would expect pixels to be here, 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 and here as well, right? But there isn't any, right? So what we would do in that scenario is, basically for our case, what we do is that for this pixel, for example, we would just take the RGB values to be the same as this pixel, just for the sake of not running into an error. So what would it look like with code? What we need to do is first get the image's size. So we would do width height is equal to img.size. I believe this is the function, or I think it's a property like that. You can just print width and height just to make sure. Yep, there we go. So this image right here, this particular image is 926 pixels by 517 pixels with that resolution. So what we're going to do now is actually we're not going to be using this image that we just loaded, and we're not going to use this to loop over all the pixels. What we're going to do is we're actually going to make another image, something called ORIG, or yeah, for original, and we're going to copy this image over, and you'll see the reason in a little bit. And what I'm going to do is I'm actually going to load the actual pixels of this image, both of these images actually. So I'm going to do pixels is equal to img.load, and this is going to actually load the actual RGB values of this image right here. So it's going to come in like a tuple, like something like this, or like a list, I would assume. So if we're like 100, I don't know, 90, 200, something like this is what each pixel would be, and there would be 926 times 517 of these pixels that I would load. And I'm going to get the pixels of the other image as well. So I'm going to call this orig.load. And what we're going to do is actually, we're going to loop over the pixels for the ORIG pixels. So for the original, we're going to call these the original image. And what we're going to do is that we're only going to use this just to get the pixel values. And by get, that basically means to see what they are. And using these pixel values, we're going to run the operation and then actually modify this image right here. If you're a little bit confused, you'll see once you write the code. So, okay, so we have the width and height. What we will do now is we'll actually make the loop. So just say for y in range height, so looping over the entire height, and for x in range width. So now we have a double nested for loop. So what we want to do now is we actually want to plan out what, accessing the neighboring pixels might look like. So let's just go back to Paint real quick. So let's just say, I'm going to erase all this. Um, okay, so we have this image again. It's going to make the boxes really quickly. Okay, I'm not going to extend them fully. Okay, so let's say we are looking at this X and Y right now. So to access the neighboring cells, which would be these cells right here, we would have to modify these X and Y values. So essentially the way that would work is that this would be X minus 1 and also, sorry, let's write that smaller, X minus 1 and Y minus 1. This would be X and Y minus 1. This would be X plus 1, Y minus 1. And just to make sure you guys understand, -1 means we go up because we're starting, let's say this is going to be 0, 0, and it's going to be 1, 0, it's going to be 2, 0. And so the x values, they increase this way, or sorry, no, the y values increase this way, and the x values increase that way, because we are looping from the top left corner of the image. So in this fashion, we can actually go ahead and fill in all the blanks right here. So this would be x minus 1 and y. This would be x plus 1 and y, since we're on the same y level. This would be x minus 1, y plus 1. This would be x, comma, y plus 1. This would be x plus 1 and y plus 1. So in this way, we can easily access the pixels, the neighboring pixels of this particular one right here. So let's just go ahead and implement that. Just right now, we're not gonna worry about this edge case right here where it's like a pixel in the corner or one of the edges. So let's actually go ahead and do that. So let's just call these different directions. So this is left. Left is basically x minus 1. Right is x plus 1, and up is x minus 1, and down is y plus 1. So let's just call these that. So left is equal to x minus 1, right is equal to x plus 1, and up is equal to y minus 1, and down is equal to y plus 1. Cool. So now let's actually go ahead and access the pixels. So let's just call this P1, P2, P3, and so on. So P1 is going to be equal to, and again, we're going to use the original pixels right here to read off of, not the image that we're going to modify. So that would be left and then up. And the reason why I made them separate like this, so it's easy to do this. So basically P1 would be this. So we'd go left and then up, or, it doesn't really matter which order you put that in, but you go left and then up. Similarly, P2, you would go just, you wouldn't move on the x, so you just keep that as x and then up. P3 would be right and then up. P4 would be left and the same y coordinate. P5 is actually this right here, so it would just be x and y. The center. P6 is x. Oh, I guess I'm gonna do right. P7, it's going to be left and down. P8 is going to be that and down. P9 is going to be right and down. Cool. So what you might have noticed is that this might seem kind of redundant, which we will address later on. But this is kind of how you would access every neighboring pixel, considering that we are going in like a radius of 1 around this pixel right here. So now let's address the elephant in the room. What do you do when you have these edge pieces right here? Well, what we can do is we can just actually look at these right here and we can check whether, so in the case that let's say we're looking at this pixel, when we look at the left pixel of this one, what we're going to get is an x value that is less than 0. So since this is 0, 0, if you look at the left pixel of this, it's going to be something less than 0. So what we can actually do right off the bat is we can add an if right here, an if statement. So if x is 0, do this. If it's not, greater than 0, then we can just keep it as x. So essentially what is this doing is that it checks, it runs its operation if the resulting, x is, or if the original pixel x is greater than 0. If not, it's just going to keep it at that. So it's going to be 0. And in the same manner, what we can do here is for the right pixel, so let's say we're looking at this pixel right here, if it gets, if it tries to access this pixel right here, it's going to access x plus 1. And the problem here is that it's greater than the width, right? There is no pixel there. So here we check if x is less than width minus 1, meaning that it's not, right at the width. And if it is not less than x minus, or width minus 1, then we just keep it as x, like we did here. Now let's look at the up and down. It's basically the same thing. If we're looking at this pixel right here, when it tries to access this, it's getting a y that is less than 0. So what we check is if y is greater than 0, then we do the operator right here. Else, just keep it as y. And just like we did the other one, we just check if y is less than height, minus 1. Else, you just keep it as y. So in this manner, we can address all these, edges and corners of the image. Now, what we need to do now is, obviously we have all the neighbors. Now, what we need to do now is actually just average all the red, blue, green, red, green, blue values of all these neighboring pixels. What we can do here is we can just set 3 variables. So total R is equal to, what we do is just keep doing this. This is a very inefficient format, but works out. Okay. So this basically accesses the first value of each tuple of each pixel here, right here. So essentially what that means is that, let's say P1 would essentially give, let's say 190, 150, right? So this is the red value, this is the green value, and this is the blue value. Total R is basically adding all the red values up of all these pixels right here, by accessing the first index of this, RGB value right here. Same thing is, we can just do total green and total blue. And what we need to do is we just end up changing all these numbers to 1. So it's accessing the second index in that list right there. And for blue, it's the third one, so we make it 2. I don't know, it's could have done with a, it could have been done much more efficiently with a list, or not a list, like a loop. But for right now, we just keep it like this because there is a much more efficient way we're going to be looking at right after. Okay, so now we have all this. What we can do is now we can actually access the image that we're going to modify right here. Just, the resultant image. So let's just call this pixels. And for each x and y that we're looking at right now, we are going to replace it with this new, you know, or I guess we can just do this here. We're just going to divide it by 9, integer divided by 9, so we can get the average color. Okay. All right, so yeah, we can just replace it with the new value that we have. And that should basically be it, actually. Now what we want to show is the new image, which is what we're modifying. And let's run this file. Okay, so actually let me just save the image so it's a little bit easier image.save to show the differences. Let's save this. Okay, so this is the old one and this is the new one. So as you can see, it's a little bit blurry. I'm gonna just shift back between these two. As you can see, this is a little bit blurry than the other one. And since we did use only a radius of 1, meaning that it's, you know, it's only a 3 or like a, yeah, it's a 3 by 3 box basically just going around this. It's not going to be much of a difference, especially since this image is what, like 900 by 500 wide. So it's a pretty decently like a decently high resolution. So it's not going to make too much of a difference. But what we can actually do is that we can make this, we can actually make it so that the user can tweak and change the radius however they want. So what we actually want to do here is that all we're changing, if the user wants to tweak the radius, is, you know, how much the thing actually, you know, how much of a radius it actually looks around for. And what we can do here is that we can utilize a loop. So what we're going to do here is actually, we're going to make this more efficient, I guess. We're going to set a value or a variable here called radius. Let's say the new radius is 3, so it's going to look 3 up. So if this is where the center, it's going to look 1, 2, 3. Very, you know, very large radius of like a 7 by 7 square, I think. So what we're going to do now is we have to change this, and we're actually, let's just get rid of all this so we can start afresh. Let's define the totals right up here, just so we can make the code a little bit shorter. Okay, it should be good. Now let me think. We probably need to set a count. So we can, okay, yeah. So what we're gonna do is actually want to set a counter. And the reason for this is because we will be iterating over every little kind of pixel in this block that we're looking at. We're gonna call it dy for the offset in y. So what we're gonna do is we're gonna look at the negative radius all the way from the negative y, which is, you know, the max we're looking at on the y, and the radius plus 1, which is, you know, the minimum we're looking at in the y direction. And the reason it's plus 1 is because in Python, for loops always end, they don't include the ending limit right here. So if we were to do just radius, and let's say the radius for like 3, it would end at 2. So which is not what we want. We want to go the full radius, just 3. So after that, we're also gonna loop over the offset in the x. And by the way, what I mean by offset is that if this were the center and we were looking at this, the offset would be 1, 2, 3. 3 offset in the y. And for this particular pixel, 0 offset in the x because it's not, you know, moving anywhere here. So let's do that in the x as well. Negative radius plus 1. Now that we are looping over every square, we are going to set a new x and a new y, which is, you know, just adding that radius onto the x and y value. So new x or nx is equal to x plus dx, which is the offset right here. Same thing for this one, ny is equal to y plus dy. And now here's the edge case again. We're going to check if, you know, we're accessing something that's outside of the image. And for this example, actually, it's going to be much easier to, I guess, understand in code, because all we're doing here is that since we have the new x and new y, all we really have to do here is just say if nx is less than 0, we, you know, or nx is greater than or equal to width, all we do is set n of x is equal to x. And by the way, the reason for why I check is greater than or equal to width is because in the way that we're accessing the pixels, the width or the index of the width is actually going to be one less than the actual width. So just to make you understand that, I'm gonna print the width and the height real quick, and I'm just gonna comment this out. So the width of this image right here is 926. The height is 517. So essentially, here what's going to happen is that when you do loop through the height, it's only going to, as I mentioned before, for loops in Python don't access the n limit. So the range basically gives all the way from 0 to 517, but the loop only ever accesses up to 516. It does not include this 517 right here. And the reason, so because of that reason, you know, we just stick to greater than or equal to width because it checks if it's greater than or outside of the bounds. Same thing here, same thing for the y. We check for if ny is less than 0 or ny is greater than or equal to height. And if so, ny is equal to y. Awesome. Now we're just going to get the new RGBs. Or I guess get the old ones. And we are just going to total them here. So this is the variables we set at the top, and we just add them up here so we don't have to, what we did before was kind of inefficient, where we just added them up manually. Okay. That should be it, I believe. Oh, I forgot to increment the counter. And then what we gotta do is actually, I guess. Oh yeah, I forgot to replace it. It's kind of silly. Pixels x y is equal to total count total g divided by count and total b divided by count. That should be it. And then image.save. Okay, so let's test it out. It's gonna replace this image right here once we do run it. And okay, it's just running it right now. It's gonna take a little bit longer since we are calculating a larger radius of images. Oh, and there you can see. So I'm just gonna, let's look here. So this is the original. This is the blurred image, and you can see this is much blurrier than what we had before. So I'm just gonna show just to show what we had before. I'm gonna call this R1, and I'm gonna run this. So this is the original. This is with the radius of 1, and this is with the radius of 3. As you can see, it's much blurrier. And just because I'm curious, I'm gonna set this to something like 7 and see what it looks like. Take a little bit longer to run. Okay, it finally finished running. And wow, would you look at that? It's a very blurry image. Yeah, it's a huge difference from radius of 3. This is radius of 7. So I hope you guys enjoyed this. It was definitely something new that I've, I've done in this video. And I'll link the GitHub repository for all this code below in the description. So if you want, you can check that out. I hope you guys enjoyed this again, and I'll be looking forward to doing more of these just kind of coding alongside me kind of videos. And thank you. Bye.